Sorry, my internet cut out there, so I had to restart the video. So I'm going to pick up where we left off. So we left off on doing proof here. So anyway, what we were saying before is that P and T are right angles, so they're provided for us, and that was in our given. What they didn't say about those right angles is that they are congruent. So what we want to say next is angle P is congruent to angle T. And the rationale is there was a theorem about all right angles being congruent. So I'm just going to say all right angles are congruent. All right, remember our goal is to be able to prove that these triangles are similar through angle. So if you look at the big triangle QPR and you look at the small triangle QTP, what you might notice is that they have the angle Q in common. So when we did congruence theorems, we looked a lot for that hidden information. And a lot of times that hidden information was a side being congruent to itself. So remember the reflexive property. In this one, it's very similar, except we're not talking about sides. We're talking about angles. So what you would say is in statement 3 is angle Q is congruent to angle Q by the reflexive property. That's because both triangles are made up with using angle Q. So it's the same angle in both triangles. Now that we've shown that two sets of angles are congruent, we can end our proof by saying triangle QPR is similar to triangle QTP, and the rationale is angle similarity. You can add in that word similarity if you want. I'm okay if you don't though as well. All right, let's try some more. Let's flip it over to page 229 on your practice, and this is just extra practice. So we're just going to kind of go through some examples. So numbers 1 and 2 say determine whether the triangles are similar. If they are, write a similarity statement and explain your reasoning. So what this is basically asking you to do is to justify how you know these triangles are similar or not similar. So it's basically a proof without actually doing a proof. So the first thing I would do is, again, use my triangle sum theorem, right? If we know this is 90 and this is 15, subtract that from 180, I would find that that angle there is 75. Likewise, if this is 75 and this is 90 and I subtract that from 180, I would figure out that that angle is 15 degrees. Now you can see that all three sets of angles are congruent in both triangles. So we can say, yes, they are similar. Our rationale is because of angle similarity, because all sets of, well, actually it's angle, but we only have to prove angle. And then our similarity statement, just make sure you match up corresponding pieces. So ABC is similar to triangle EFD. So ABC and EFD. And that's your similarity statement. For the second one, again, same kind of process. I would start with like the triangle sum theorem and I would figure out what the missing pieces are. So I got 106 here. If I subtracted those, I got 34. So what I can conclude here is that even though I have one set of angles that are congruent, I definitely don't have two. So this is not similar. And I'm sad, apparently. Explain your reasoning. You could just say something like only one set of congruent angles. Yeah. All right, number 3 and number 4 we're actually going to do as proofs. So I'm going to have you do a 2-column proof for 3 and 4. So it says show that the two triangles are similar. So there's a couple ways you could do this. It doesn't actually tell you to write a proof, but I'm going to have you guys do that anyway. So statements and reasons. So again, this isn't like a formal proof, but what you have to pay attention to is what's provided in the diagram for your given. So our goal is to be able to prove the two triangles are similar. So we're talking about the big triangle. So our goal is to prove ACE is similar to triangle BCD. So the big triangle and then the smaller triangle. That's our goal. So statement number 1, I'm going to say that AE is parallel to BD. And my reasoning is that they were given. All right, if we know lines are parallel, so this is kind of the same strategy that we used when we talked about congruence, right? If we know lines are parallel, then we know something about their angles. So I'm going to label this set of angles here 1 and 2. And the only reason I do that is to make it easier on myself. Don't have to do that. I'm going to state that angle 1 is congruent to angle 2. I'm also going to label, let's see here. I'm gonna label, well, 1 and 2, I guess, and then I'm gonna label 3 and 4. So what you want to do is you want to think about why these angles are, so we know that they're congruent, but why? So if I extend out my line, sometimes it helps me to extend out my lines. What do we call the angles that are in this position here, like angle 1 and angle 2? So if those lines are parallel, cut by a transversal, what do we know about those angles there? So if you said corresponding angles, then you would be correct. So you would say corresponding angles are congruent. And so that's our justification. So I know in the congruence proofs, a lot of times we used alternate interior angles are congruent. And while that's, obviously a good one, it's not as popular when we talk about similarity. You could also state the same reasoning for 3 and 4. So if you extend out the lines, you will see that 3 and 4 are also similar. So you can combine that into statement 2, or you can make its own statement and say angle 3 is congruent to angle 4 by corresponding angles theorem. I'm just gonna do the little ditto sign. And then finally, I'm gonna end with triangle ACE is congruent to triangle, or not congruent, similar to triangle BCD. And my rationale is angle-angle similarity. All right, let's try another one. All right, number 4, similar, right? We've seen stuff like this before. So again, our goal is to be able to prove that these triangles are similar. So the two triangles we're talking about are triangle PQS, which is the top one, is similar to triangle RSQ. All right, so let's start. Well, we were provided that P is parallel, well, PQ, I should say, is parallel to SR, and we were given that PS is parallel to QR. All right, now that we know lines are parallel, there should be some stuff that we can say about all of their angles. So in particular, if I have these two sides are parallel and this is my transversal, what do I know about this angle and this angle? Likewise, what do I know about this angle and this angle, given that these lines are parallel and cut by a transversal? All of those are what we call alternate interior angles. So you could say angle 1 is congruent to angle 2, and you could say angle 3 is congruent to angle 4. So I'm going to do that in one statement and just say alternate interior angles are congruent. Now that I've showed that angle 1 and 2 and 3 and 4 are congruent, I've got my two sets of angles. So now I can say that my triangles are congruent. So triangle PQS, and I keep saying congruent, but it's similar to triangle RSQ, and my rationale is angle-angle similarity. All right, so to be honest with you, that's all I have. So it's kind of a shorter video, or videos. I apologize for the mix-up there with the stopping. What I'd like you guys to do now is to practice some of this on your own. So go on to Big Ideas, practice some of the problems there. There's not going to be a lot in this section that have you write out proofs completely, but you can still practice it. So like even though these directions on this extra practice didn't say, oh, write out proofs directly, you can still do that as kind of a practice in getting you to write proofs, because that's going to be a useful tool in this unit. We're going to be doing some proofs in class as well. All right, bye for now. Bring any questions you have to class.